Thanks for watching this screencast. The objective for the screencast is learners will be able to, given a polynomial function, describe the end behavior of the function. So a polynomial function we should define before we talk about the end behavior is any function whose rule is a polynomial. Here's one example of many. F of x equals 2x to the fourth power minus x squared plus 5x plus 3. Any polynomial, if you write the function f of x equals that polynomial as its rule, is a polynomial function. And the purpose of this screencast is to introduce you to one important characteristic of the polynomial function, which is its end behavior. The end behavior of a polynomial describes what the function graph looks like for large positive and negative input values. Okay, let's take a look at this very odd set of pictures for a minute. So what you're looking at is an individual doing a dance that one of my former students, when I taught in Petersburg, called the end behavior dance. There are 4 different types of end behavior that a polynomial function can have, and depending on the leading coefficient and the degree of the polynomial, it will look like one of these 4 dance moves. So the first dance move here in the top left corner, this individual is dancing here, and his arms look like every polynomial function that has an odd degree. Remember, the degree is the biggest power of the term in a polynomial, and a positive leading coefficient. So the term that has the degree in it, we're going to decide if the term itself is positive or negative. If the term is positive and it has an odd degree, I'll kind of add the axes in here, the end behavior will look a little bit like this gentleman's arms. So the end of it for big positive x's will have big positive y's. It'll do whatever it does here. For big negative x's, it'll have big negative y's. So as x gets closer and closer to negative infinity, well, y is approaching negative infinity as well. We're getting bigger negative y's. But for here, as x approaches positive infinity, y is approaching positive infinity as well. Now look here on the top right. What happens for a function if the degree is odd, but the term that has the degree in it is negative? It's a negative leading coefficient. Well, then it's the reverse. Then for big negative x's, we have big positive y's, or in other words, as x approaches negative infinity, the y's approach positive infinity. And as we have big positive x's, we have big negative y's. As x approaches positive infinity, y approaches negative infinity. Now, what if the degree is even? Well, if the degree is even, then the end behavior is the same for both positive and negative x's. If the leading term is positive, then the end of the function looks like the gentleman's arms here. So as x approaches as x approaches negative infinity, y approaches positive infinity, and as x approaches positive infinity, y approaches positive infinity. So what if that leading term is negative? Well, then it looks like this. Both directions, we would say, as x approaches negative infinity, y is approaching negative infinity. And the same is true as x approaches positive infinity. As x approaches infinity, y approaches negative infinity. And those are the 4 different types of end behavior that a polynomial function could have. Let's work a couple examples here of the type of question that you'll need to be able to answer from this learning target objective. Here's a polynomial function, a function whose rule is a polynomial. It says describe the end behavior of each function. So let's look at f of x equals x cubed minus 3x squared. And what I want to do is I want to find the term that has the biggest power of x in it. In this case, it's right here. And I want to look at that term to decide whether the degree is odd or even. The degree is 3. So the degree is odd. And I want to look at the sign of that term. That's just x cubed, so it's a positive term. A positive leading term. Which step of the end behavior dance was that? I'll look back. A positive leading term with an odd degree is this move, right here. So, without drawing the whole graph, I know what the end of the graph looks like. It has big positive y's when I have big positive x's. And it has big negative y's when I have big negative x's. So, as x approaches negative infinity, this way, the y's are approaching negative infinity as well. As x approaches positive infinity, this direction, well, the y's are approaching positive infinity as well. So there we go. This is the end behavior. Here's another example. G of x equals negative x to the fourth minus 4x squared. The term that has the biggest power of x in it is this one. Notice the importance of this negative sign. This is an even degree. The degree is 4. And the leading term is negative, a negative leading term. That's this move, an even degree with a negative leading term. So I need the end of the graph to look like this. So I'll make a sketch. So for big negative x's, I've got big negative y's. For big positive x's, I've got big negative y's. As x approaches negative infinity, the y's are approaching negative infinity as well. As x approaches positive infinity, the y's are also approaching negative infinity. Okay. Hit pause, see if you can describe the end behavior of the function, and when you think you've got it, hit play to get some feedback. For f of x equals negative x cubed plus 2x squared minus 2, the term with the biggest power of x in it is this one right here. This is an odd degree, but it's a negative leading term. So which step of the end behavior does this look like? Well, it starts up here, does whatever it's going to do, and then finishes this way. As x approaches negative infinity, the y's are approaching positive infinity. As x approaches positive infinity, the y's are approaching negative infinity. Here's g of x equals x to the fourth minus 3x squared plus 2x minus 2. The term with the biggest power of x in it is here. The degree is even. And it's a positive leading term. So what does the end behavior look like? Well, both directions on the x-axis, the y's are approaching positive infinity. So as x approaches negative infinity, the y's are approaching positive infinity. As x approaches positive infinity, the y's are also approaching positive infinity. Thanks for watching.